Right, let's kick it off. Hello, welcome to Slooh, now home to 24/7 live astronomy. That's right, wherever you are around the globe, you'll have access to Slooh's live online telescopes, weather dependent. Um, I would just like to say thank you very much for all of those who have either got up extremely early or stayed up late to join us today for this exciting event. I can see we've got people from Europe, we've got people from North, South America, Israel, Canada, New Zealand, and Australia, to name just a few. But anyway, we are thrilled to announce the launch of our new observatory in Siding Springs, the astronomy capital of Australia. Now, the new observatory is located in the heart of the Wollongong Dark Sky Park at the Southern Robotic Observatory facility. We call it SROF for short. It's got unparalleled skies. The location's been officially recognized for its scientific value and natural beauty, and it's an absolutely perfect spot for our new observatory. Now, the observatory houses Slooh's new premier Southern Hemisphere telescope, a plane wave CDK-20 half-meter telescope. It's equipped with an ultra-sensitive research-grade CCD camera. It's basically the twin of Slooh's Northern Hemisphere half-meter telescope at the Institute of Astrophysics of the Canary Islands, a popular telescope. Now, the location enjoys what are considered to be the best skies in Australia. It's recently placed into law in recognition of that, of the significance of the location for that scientific value. Now, with the addition of the new Australian observatory alongside Slooh's existing Canary Islands and Chile observatories, students and members now have access to 24-hour live coverage of the night sky. That is huge, especially for people like me in Europe, or Carol down in South Africa, or maybe Roy and his students in Israel, and of course, all of our Indian students who are now going to have live telescope feeds during normal school hours and normal daytime hours. We're going to talk about all of that a little bit later on. But without further ado, I guess, let's take a look at the website so you know where to find the new observatory. It now appears on the dashboard. Hopefully you can all see all of this. There it is. We got 3 observatories showing up in there. Now, you'll be able to access it in exactly the same way by clicking directly on any of the online telescope links there. You'll see that Australia isn't live at the moment. We'll go into that in a second. You can also use the telescope button in the nav bar, of course. So if you scroll up the page, you want to get straight to it, you can come up here and you can scroll. Gosh, you've got to scroll down to get all of the telescopes now. And we can come all the way down to Australia, and there's the horrible message that we were kind of anticipating tonight. Nothing we can do about that, but we're still going to celebrate the launch of the observatory. So let's take a look. You've spotted it. Yeah, it's really thick nebulosity. But shall we take a quick look at the all-sky camera? There it is. This is one from the SROF. The bright light over there is the moon. We can just about see through those earthbound nebulas, the Milky Way stretching across the sky. I see Cameron's joined us as well. Cameron, you're going to be part of the conversation later with some other stuff that I've got to talk about. Now then, where are we going to go? So we've got some pretty horrible weather, but you are going to really enjoy these views that we've got. We've got 2 all-sky cameras here that you can peruse. That one's actually at the MOPRA facility. This one, though, is actually going to be my favorite ever camera that we've got for live telemetry. You can't quite see it there, but if you guys kind of log into this, you can just see the silhouette of the new Australia 1 half-meter telescope hovering there in the background. There's a great time lapse of this, so actually you can see it even better. Hopefully this will might fill the screen. Yeah, it does, unfortunately, so you can't see it. Oh, you can see it a little bit there, but there's the telescope. And excuse me, on opening, you'll see that whole roof slide back, and that time lapse, I have seen it when we were doing a pointing run of seeing the telescope flipping around all over the sky is quite good fun to watch. But we're still going to have a look around, even though we're weathered out today. Let me just close that time lapse. So let's take a closer look actually of where the new observatory is located. So hopefully the Google Maps come up. There's a link on this I'll show you in a second. There we go. For anybody who's not aware of where Australia is, it's on the opposite side of the world to the UK and the US. And you can see that the Slooh Australia Observatory is located on the east coast of Australia. So let's take a zoom in. Here we go. We're going into New South Wales, zooming in even closer. Now, what you'll start noticing as I zoom in on the location is the population of towns gets lower and lower and lower. So here we go. We got surrounded by national parks. Here we are in the Wollongong National Park, protected by law now, just like the Canary Islands are. Zoom even further, we see the Siding Spring Observatory. I've been describing this as we are literally a stone's throw away from the Siding Spring Observatory. And if we zoom in closer, here is the SROF facility, and we are located in this little roll-off structure here. So that's, you're going to be controlling the telescope halfway around the world for most of us. All right, so I think that's pretty good. Now then, let's just go back. Let's hop back to the Oz1 telescope page a second to learn more about this huge telescope. Students and members now have the ability to control. Now, at this time of year, if we scroll down the page, actually, at this time of year, the observatory operates. So don't forget, we're in kind of midwinter in Australia, hence the weather. But it's going to be operating at this time of year about 12 hours a day. Starts up about 08:15 UTC all the way through to 2000 UTC. So that is a marvelous overlap as well for students on the East Coast, and even starts bringing in the school day on the USA West Coast as well. Now, to learn more about the new observatory and the telescope, you can visit the Australia Observatory Guide page. If you don't know how to get there, you click the little magnifying button, you come down here to the Australia Observatory, and here it is. It's got all the blurb in here. It's got some coordinates in here. It's got that little location map as well. So if you are using planetarium software, these are the coordinates that you're going to need to add to that if you use planetarium software to help plan your missions out. So there's loads of other info on here as well about that. But actually, if we scroll down to the bottom, we can learn more about the Australia 1.5 meter telescope as well. So here it is when we talk about the size of a telescope, half meter, we talk about the diameter of the primary optics, in this case, the mirror, the reflecting mirror that sits at the back of the telescope. There's a secondary mirror as well on this particular telescope, which frankly is the size of most people's telescopes at home. But 20 inches, that's 508 millimeters, extraordinary light gathering capabilities. Now, it's mounted, so it's a plane wave instrument, CDK20, as I said, which is identical to the Canary 1.5 meter telescope. You can see our designation here, A1 wide field 508. It's equipped with a Fingerlates Proline 16,803 CCD camera. For those of you who haven't seen one of those up close, I know a lot of you have, but this is exactly the same model. So you can see it's all about the cooling in here. It's got loads of ports on it as well to power up ancillary equipment. The huge shutter, iris shutter, is behind that piece of cardboard being connected. This thing cools down the CCD sensor itself to around minus 40 degrees C. So the actual chamber that that sensor sits in has to be filled with an inert gas, so it has no moisture. Otherwise, we have seen this sometimes when the camera needs maintenance. It can land up getting frost inside the actual camera. So I've seen a load of other people joining while we're talking about as well. Jenny McLaughlin's come into the house. Keith Smith's down there as well. Anyway, so that's the camera. Now, filters. Most of you know that our cameras, because it's a grayscale camera, so it has a huge filter wheel. Filter wheel is about 16 inches in diameter, and it has two carousels inside. if you have a look on the website, you'll see I've got a couple of videos on there because it's really interesting to see how that works. It has two carousels in there, basically so it doesn't have to be so big to fit so many filters in. If you can imagine, it would have to be enormous to have them all on a single carousel. So that's a really good way of doing it. And it also means that the weight of that filter wheel is also centered on the whole thing. But you can see here we've got our normal luminance red, green, blue filters on here. We've also got an H alpha filter on here as well, which will use the moon special events and stuff like that. For those of you who are into the science and all that kind of stuff, you can actually see the bandwidth wavelength ranges for each of these filters. Unfortunately, we couldn't match the filters to the other observatories because they're no longer made. So these are filters from Chroma Technology. So the color balance will be slightly different when you process your own images from this. These filters, by the way, are absolutely huge. They're 2 inches square. And they have to be that big because the sensor in that camera is enormous. I think it's in the spec sheet up here. You can see it's 37 millimeters square. So you need to have filters larger than that, otherwise you get vignetting on the corners. So we're talking about filters. So we got the normal LRGB ones, luminance red, green, blue. That's what we have that patent for, to process all of that data in real time. There's the H alpha filter as well, giving us a very, very narrow bandwidth. We basically use that as a neutral density filter when we're trying to image the moon with these larger telescopes. We also have some photometric filters installed. B, V, and R, Johnson Cousins Bessel photometric filters. These are installed hardware-wise, but they're not going to be available until later this year, when we're also going to be enabling those for the Canary 2 and the Canary 1 telescope as well. That's really important for our new research and graduate student accounts, as well as our astronomer accounts that also have access to those. See the image specification here. So very, very close to the Canary 2 wide field and Canary 1 half-meter telescopes. Field of view is roughly the same as well, 37 arc minutes square. Now, the thing to think of here is, although it's a half-meter telescope, it's not exactly the same. The telescope itself is to the Canary 1 half-meter, but we've actually got a different combination here. So we've got the same camera, which is installed on the Canary 2 wide field telescope, which is that one I just held up there, but it's on a half-meter telescope. So the specifications, the image field of view is very close, but it's not identical. The image scale isn't the same either. It's mounted on a brand new software BISC Paramount ME2 German equatorial mount. And I'll tell you, that has been operating really, really well. I haven't seen any wind blowing at all, which you'll be pleased to hear. By the way, when we redevelop the Canary Islands Observatory, the half-meter telescope there will be a lot more protected from the wind. So that's going to be absolutely brilliant as well. We're not in a dome at the new observatory. It's a custom enclosure, as I showed you on that map. There it is. It's a roll-off roof. I don't know if I can zoom in any closer. I can. So here we go. You zoom in on this, and that whole roof of the building basically slides off onto these rails. Walls are quite high. We've still got quite a good low horizon for us. You should be fine, 30 degrees, 360 degrees around. And then slightly lower in different places just because of the way the telescope works. So, right, let me catch up. We're going to have some Q&A as well. So if this is prompting any questions, we will have a little Q&A session. So let me catch up. I've done filters, I've done their camera. So how do you schedule missions? Well, scheduling missions with the new Australian 1 telescope is exactly the same as the other telescopes on the network. Now, you can't do that yet because I haven't enabled reservations, and I'll do that at the end of this star party. But one difference you'll notice with the Australia 1 in comparison to the Canary 1 half-meter telescope is that missions are 5 minutes long rather than the 10-minute long Canary 1 half-meter missions. Now, we often have to reduce the exposure duration on these larger telescopes to avoid saturation. That's when, a bright object This basically overwhelms the CCD. So you start losing resolution, stars start to bloat and stuff like that. It's basically having too much light gathering capability. And of course, having 5-minute missions as well also doubles the number of missions which are available on any given night in that. So here we are. So I will enable missions at the end of the star party, but let's go over for a little bit of Q&A. Let's hop back over to the telescope, make sure we're not missing clear skies. We're not. These time lapses, by the way, absolutely brilliant. If you open these yourself, unfortunately, I can't open any bigger than that. You can see one of the big radio telescopes here at Siding Springs. They have had, while I've been testing over the last month or so, slightly longer than that actually, we can sort out the ratio of that SROF all sky as well. They've had a very unusual bout of weather down there, incredibly high humidity. They normally see humidity, really quite low down. So let's just close those time lapses because we will just hop down the page. So you can see we'll have status reports as normal. The satellite view is not working at the moment, but the engineering team are working on that. We have a look at the weekly forecast tonight. We got chance of rain. Now, at the risk of depressing you, I'm going to click through the weather forecast. Friday, rain. Saturday, partly cloudy. Sunday, mostly cloudy. Monday, mostly cloudy. Tuesday, chance of rain. Wednesday, chance of rain. So this is what typically happens when you buy a new telescope or you set out an observatory. It normally means that the weather forecast is going to be pretty darn dodgy for the following week. But I tell you, it's going to be worth the wait when it comes online. Here's our new daylight map. Isn't this great to see? 3 observatories. And you can see here that there's an overlap between the Australian observatory coming online and the Chile observatory being online. So just imagine this opportunity of being able to watch live missions. And we're seeing all of those objects at the end of Chile missions at the end of the night that are returning to pre-dawn skies. But we've got all of those last chance objects in evening twilight at the Australian observatory. And of course, look what's bang smack in the middle of this at the moment. We've got the sun. So we've also got the solar telescope, of course, filling in some of those gaps. Now, there are, I think when I went through the timings of all of the opening times for the 3 observatories. There are a couple of times a year, I think, where we kind of miss an hour or less than an hour. But to all intents and purposes, if the weather is fine, we are going to have 24/7 observing, and then throw the solar telescope in there as well. And things are looking pretty rosy, I think you'll agree. We've got the normal moonlight widget in here as well, all of the normal stuff as well. Sky conditions in here. We've got the live telemetry coming in from the site. This is what's been bothering us recently, the incredibly high humidity. So keep an eye on that. We've also got the day-night bar as well, which can help you, shows you when missions are launching and stuff like that. What else have we got in here? So don't forget, actually, we're going to talk about this after we've done a little bit of a Q&A. A lot of members miss the fact that Slooh operates in what's called astronomical twilight. Now, that's the first 30 minutes of missions and the last 30 minutes of missions. Now, astronomical twilight means that astronomical darkness hasn't fallen. Now, if you schedule faint and fuzzy objects like nebulae, like fainter galaxies, your images are going to have all sorts of gradient over it because the sky's not totally dark. So what you need to do is in those first 30 minutes or last 30 minutes, unless you're chasing an object that's only visible in those periods, like a comet or an asteroid, it's best to stick to brighter objects. The moon, the planets, stars, globular, and some of the brighter open clusters as well. And they're far more robust objects when it comes to having a little bit of a brighter sky in the background. So I don't know if we've got any questions. I don't know, Gretchen, have you opened up people's mics or am I looking at chat?
I threw some questions for you in Slack.
In Slack. Okay.
Yeah,
Oh,
put that
there's
up.
a
Yeah,
surprise. Thank you very much. Thank you very much.
sure.
Gretchen's on it, given it's what time did you say it's over there at the moment?
It
3
is.
a.m.
It is It's late. It's
Right.
4:19 a.m. It's way past morning.
I want to see in chat. Um, Kane, right. Kane's just talking about when it's going to open. Um, I want to hear in chat who is at the worst possible time? Who has turned out in the middle of the night for this particular one? You've got people like Keith Smith, he's in daylight down under. Roy is certainly in daylight in Israel. But I think it's most of our North and South American guests who are waking up quite. Yeah, Roy's saying he's having lunch. What a great way of spending lunch to see the launch of a weathered in New Australia Observatory. Roy, I hope your students are going to enjoy this observatory. It really is going to be absolutely cracking. So for them. Right, so there were some questions in here. So Roy Gavish, what is the expected minimal brightness? What do you mean by that, Roy? Do you mean what's the limiting magnitude of that telescope? If you do, it's going to be, yeah, so under kind of normal circumstances, you're probably talking 19 easily. But I do know that some of the near Earth asteroid tracking team, the A team, I know that they have managed to get down to, I think, magnitude 21 with the half-meter telescope, longer exposures, combining mission data as well. So it's going to be pretty good. I mean, this is actually a great combination of that particular telescope, the half-meter telescope, and this particular camera as well. It's an absolutely great combination. The camera itself is absolutely cracking. Very few bad pixels, very few bad columns. These are the things that we have to calibrate out. The existing or the camera that is on the Canary 2 wide field system at the moment is one of the older cameras, and this one is going off for refurbishment. So this one was an absolutely spanking camera when we put this on. So that's going to be going back on when we redevelop the Canary Islands Observatory. Franz is asking, what is the plan for the future of using H alpha for a normal user? None whatsoever, I'm afraid, Franz. For the majority of objects, you need very long guided exposures to get any kind of light from nebulae, any kind of usable light for the H alpha filter. It cuts out such a tremendous amount of the light. So no plans to do narrowband imaging using H alpha or some of the other filters that we've got installed at some of the observatories like Sulfur 2. Um, Comment from Keith Smith. It's going to be interesting to see how the same object looks like in A1 compared to T1. It is. Now, I've already done a couple of comparisons. Of course, there's not a huge amount of crossover in the sky coverage. Um, if we look at the map again, the day-night map, we can see that although the Canary Islands can grab quite a few objects, in the south, I think down to a declination of about -20 or something like that for advanced missions, maybe somewhere around that. There's not a huge amount of crossover, and frankly, most of the what I would call showcase southern hemisphere objects um, are a lot further south, so they're not visible from the Canary Islands Observatory at all. There are some great exceptions to this. So all of those wonderful objects in the Milky Way, a number of them are visible at the moment. You've got the Lagoon, you've got the Trifid, you've got the Swan Nebula as well, the Lagoon Nebula. There are some interesting comparisons. Now, when you see the first images come in, as soon as the weather clears and we see the first images coming in from the Australian Observatory, you'll notice that the color balance is slightly different to the other telescopes, and that's because there are different filters. So we are going to be calibrating those more. We've got a huge calibration library already with some great flat field frames. If you remember, we use 3 types. So these cameras, they produce raw fits files. There's lots of noise, there's lots of stuff, there's lots of artifacts within those raw images, both the vignetting from the telescope, any dust spots on either the sensor or any of the optics appear as donuts. rings on the images. Now we take, and as well as all of that, the sensor itself, even though it's cooled down to -40 to reduce the amount of electrical noise on the sensor, you still get some noise generated. But thankfully, the electrical noise is measurable at any given exposure duration and temperature. So what we do is we take 3 types of calibration frames to remove those artifacts. So we have a bias frame. Bias frame isn't used that much because we tend to match everything else, but they come in handy if you haven't got an exacting matching calibration frame either for the exposure duration or the temperature, and a bias frame is used to scale that calibration frame to make it more appropriate for use. The second and most important, probably, of all of the calibration frames are dark field frames. Now, those are the ones that measure that electronic noise. They also measure and allow us to capture bad pixels, bad rows, and we subtract those from the image as well. The last, probably the most difficult for astronomers to capture a good set, but I've got a really, really good set for the Australia 1 telescope, including for the photometric filters as well. These are called flat field frames. And what these do is they capture, and we take hundreds of these things and then average them out because it makes it more accurate, and it means that individual artifacts are kind of ejected from that larger sample. So what we land up with is an image. I've shown this on some of the previous shows, an image that has a dark silhouette around it. So that is going to be used to remove the vignetting, which is visible in all of the raw images, but also all of those dust motes, all of those little donuts. It records all of those, and those are subtracted from all of the raw images to produce a calibrated file, which hopefully removes the vast majority of those artifacts. So I hope that answers that. So Rick Anderson is asking, looks like the observatory had lots of room for growth. If and when will you add the same space? Add in the same space. We've got no plans at the moment to add a second instrument here. The next project that's underway is the new dome in the Canary Islands, Dome 4, which is going to house a second half-meter telescope. Not sure exactly how that's going to be used. It's probably at the outset going to be used for normal operations, but we are also investigating a research dedicated telescope. So there is that possibility. So no further plans at the moment, Rick, for further expansion down there. Let's get this one off and running first of all. But as you can see in the roll-off roof, there is some room there. Jeff is asking, are there any plans for an ultra-wide field telescope in Siding Springs? None at the moment, Jeff. So it's fairly difficult, actually, when you've got the half-meter telescopes, to add any kind of piggybacked instrument, even if it's a small refractor, because these mounts are kind of at their limit with the half-meter telescope. I mean, this thing alone, I don't know, I'm estimating that probably weighs, it's a good 10, is probably 12 pounds. You know, it's about, yeah, it's probably about 6 kilograms, something like that. And that's strung off the back of the telescope. It takes 3 people to move a half-meter telescope. It takes 2 people to move a 17-inch telescope. And if you can imagine the size of the telescope, when it's mounted on top of the mount, you've got this increased moment because it's, you know, the heavy stuff is even further away from the axis of the mount. You know, so the weight capacity of the mount reduces dramatically the larger instrument you go up. So if we were to stick on a ultra wide field small refractor or something like that on top of that telescope, we're going to be damaging tracking, we're going to be damaging pointing accuracy and stuff like that, and basically just stressing them out. Don't forget that a lot of telescopes of this kind of size, we're quite rare in this because of what Slooh does in comparison to a telescope rental service. A lot of people who are using telescopes like that are probably pointing to a single object for hours on end. So the telescope actually only has to go through that kind of heavy duty cycle of slewing and moving all of that mass once, and then it just sits there and tracks gradually, which is not really putting on um, very much load to the mount. Um, so anyway, we got no plans at the moment. So, but I think the field of view is pretty well matched to the vast majority of objects we've seen with the Canary 1 and the Canary 2 wide field telescopes. You know, especially the Canary 2 wide field telescope. It's a great all rounder to get planets and smaller objects with some digital cropping and binning one to one and all that kind of stuff, um, as well as those large diffuse objects like large galaxies, large nebulae, and stuff like that. So it's a sweet spot. It's a sweet spot that we've got. Where did I get to? That was Jeff. Kane, what are we targeting this time of year in Australia? Well, unless there are any other questions, I think we will go on to that very subject, Kane. So any other questions coming in?
No, that's it for now.
Yep. Cameron was just asking, has the CDK 20s changed since Canary 1 was purchased? Or is it very similar scope? Um, it is, the optics are identical. The construction has changed a little bit. The electronics have changed slightly, but from a user point of view, you won't see any difference except this one is brand spanking new and out of the box. Although when I went to the Canary Islands a few weeks ago, which is where I got this horrible lurgy from. The half-meter telescope is in remarkably good condition. So too is the CDK 17, the Canary 2 ultra wide field, wide field as well. So, any other questions before we go on to the next subject? Yeah, and Carol's just realised that she can watch Australia 1 and the Canary 5 at the same time. And of course, there's also a little bit of crossover at this time of year between Canary 5, especially when I'm operating it, and um, the Chile telescopes as well. So that's pretty good. Any plans to check up on C1 at any point? Don't know what you mean there, Keith. We'll try and keep this focused to Australia at the moment. We've got a maintenance visit. I mean, Chile 1 is. Oh, which one are you talking about? See, C1 is Chile 1. There's a blotch on it. So why didn't you email me or email support, Keith? That's always the best way of reporting stuff like that. Let me know. It might just need a new flat fills. Okay, Chile 1 might just need new flat fills on it. Maintenance visit scheduled for the beginning of summer or spring there later on this year, probably to coincide with the annular eclipse, which is visible from Chile and southern tip of Chile and Argentina. And this is actually going to be, it's quite interesting. I don't know if you know this, and I'm really crossing fingers, and all of you should do the same, that Australia 1 is going to be as, dare I even say it, as reliable as the Chile 2 telescope. Somebody can remind me in chat when we launched the Chile 2 telescope. I think that's nearly 5 years ago. That telescope has not had a single night's downtime through a technical issue all of that time. We haven't had to have the guys at the Puck University, the Catholic University, intervene to even press a button down there. Yeah, let's cross fingers that Australia 1 runs the same. Now, there's another difference actually that everybody might not know about with Australia is this is the first time that anybody other than myself has installed equipment at any of our observatories. And the guys down there, Paul Muller, the guy who runs the SROF, very well experienced. I did share some of my magic observatory dust with him so he could give it a sprinkling of that. So cross fingers, everything's going to run well. But let's move on because we had, let's just check the conditions once again, make sure we are not missing anything. By the way, you'll notice that the timestamps on the all sky cameras down in Australia, I nearly said Chile there, gosh. Down, when I say down in, normally means Chile. We can still see some Milky Way here coming through, but that is not sufficient to open, not with that risk of rain. But you'll notice that the timestamps are different. I have asked the SROF if they can change that to UTC. What I think surprises me most is that the professional observatory here, the MOPRA, that they don't use UTC, which I just find quite surprising, really. So maybe down under, Paul. Yeah, that's what Keith's saying. Down under. So let's have a quick look at the telescope. Everything look is still all intact. There it is. You wait until you see this view. Honestly, it looks so good, especially in twilight when the roof is open. You see the telescope and mount very, very clearly. And then just in that astronomical twilight that I was talking about, you see it clearly still, slewing around. When it's moonlit as well, um, then we do get, you can see really well in the observatory as well. But anyway, let's take this opportunity now. Keep the questions coming if you want them. Um, to discuss the first light competition. Now, we haven't got first light tonight, unfortunately, because of those weather conditions, but if you don't know what first light is, it's the first time a new telescope captures the light from a distant object. And we ask for your suggestions for what object that should be. Now, bear in mind, I have done testing on this telescope. But I kind of class that as technical first light, really. I've done pointing runs where I've captured, you know, 400 stars to make sure that the pointing of the telescope is absolutely perfect. But we class First Light really as the first member mission. Now, members have made some suggestions. So I did make a post in fact, I think I'm not going to be able to get to it here. I'm not going to be able to get to it here because I'm logged into the wrong account. But if you hop over to the Astronomers Anonymous workspace, you'll see that some members made suggestions. And thankfully, I wrote those down, given that I'm in the wrong account here. I'm just going to hop over to the telescope page. Actually, why don't we take a quick look at Canary 5 while we're here? Andrew Dumbleton is controlling it. Oh, look at that. Look, there's a flare underway. So when you see that really intense, so here we've got large active regions and they're quite bright. As soon as you see them looking this bright, you know that that's an active flare. That may only last a few minutes, can last longer than that. But some of these we've been seeing recently, especially associated with this sunspot group, have just come and gone within a matter of minutes. So we're going to click that. Got that. So, right, while you're watching that, let's go back to the suggestions that were made. Now, Carol Botha suggested, hi, Carol, the glorious globular cluster Omega Centauri. And that is a perfect object if it's at the beginning of the night before astronomical darkness falls. And that's that first 30-minute submissions that I was talking about. Byrne agreed and then suggested moving on to the active galaxy Centaurus A, which always looks spectacular in the southern hemisphere scopes. Now, I am still tuning up the processing options because I have been really quite surprised that I knew there was obviously going to be a difference between the CDK 17-inch telescope, which is the Canary 2 and Chile 2 telescopes, and a half-meter telescope on some of these objects. But some of the processing, we are actually gathering too much light on them, even in a 5-minute mission. So I will be maybe knocking that back or changing the process. Cameron suggested, though, several objects. Some showcase Southern Hemisphere. Hi, Cameron. Thank you for joining us. Showcase Southern Hemisphere objects such as Carina, Carina and Eta Carinae nebulae, the Tarantula Nebula as well, and the Globular Cluster 47 Canary, which I adore all of those objects. Don't know if anybody remembers. Can somebody look up what our first light object was for the Chile 2 telescope when we did our first light star party a good number of years ago? I've got a sneaking suspicion it may have been the Tarantula Nebula, but I can't remember. I should do. I should have that emblazoned on my mind. But anyway, Cameron went on to write this, and I think for those of you who haven't got access to the Astronomers Anonymous workspace, I think it's worth reading this out from Cameron because it's a delightful piece of writing. Thank you very much, Cameron. And Cameron wrote, I think a first light object should be an object of significance and intention. So you can see where he's going here. One that represents the values that Slooh has, the gathering and sharing of knowledge, history, and culture, and the transcendent joy and wonder of looking up together at the vast landscape of the cosmos. Um, I couldn't have said that better, and I literally could not have said that better. I think that's a beautiful piece of writing. Thank you very much, Cameron. But he goes on to say, for me, the constellation of Crux, the Southern Cross, the smallest of the 88 IAU constellations, holds such significance. The Southern Cross holds significance to many southern nations. It appears on the flags of Australia, Brazil, New Zealand, which is his home country, Papua New Guinea, Samoa, and in the words of several of their national anthems. And like the Northern Pole star Polaris, it holds a significant place as a celestial point of reference and navigational aid. Goes on to say, and even though Crux, the Southern Cross, is too large to fit in the field of view of the half-meter telescopes, its stars are not, and there are at least two objects of significance that stand out in the constellation Crux. And the objects that Cameron is suggesting is the orange-hued star Jinan. I don't know if that is the correct pronunciation, but you know me, we should never get held up in correct pronunciation to stop us enjoying our hobby. But that is the scientific name for that is Epsilon Crucis, which I can pronounce, thankfully. And that's the fifth star of the Southern Cross and appears on the Australian flag. So, Cameron, this is a wonderful write-up, and we're going to add this to the Slooh 1000 because I did check to see if it was there already, and it's not. Um, but this would be a wonderful star, and I did look at it, and it's a beautiful orange color. So we'll have to get the processing just right on that. So, anyways, fifth star of the Southern Cross and appears on the Australian flag. This star holds the traditional name Jinan. Ginan. Try and tell me in Slack. Try and show me phonetically how that's Ginan. Okay. Hopefully pronounce that right. Thank you very much, Cameron. He's just told me that in chat. Um, so where are we going now? The star holds traditional name Ginan in the culture of the Wardaman people of the Northern Territory of Australia. It's also the official star's IAU name. The name refers to a dilly bag, and if you look at the post, Cameron's got a picture of that. It's a traditional Australian Aboriginal bag. The second object that Cameron suggests is the jewel box, a beautiful A-shaped asterism of stars near Mimosa, which is Beta Crisis or Crucis, I think, in your post. It's the second brightest star in the Southern Cross, right? So it's Crucis. This asteroid, named the jewel box by the English polymath John Herschel, is, in his words, an extremely brilliant and beautiful object when viewed through an instrument of sufficient aperture to show distinctly the very different color of its constituent stars. Well, I think the new Australia half-meter telescope fits that bill. Instrument of sufficient aperture. And Cameron then just finishes off by saying, which give it the effect of a superb piece of fancy jewelry. That's what John Herschel said. John Herschel was William Herschel's son, and John actually did a lot of work in the Southern Hemisphere, whereas, William and Caroline were really kind of Northern Hemisphere observers, but John Herschel, his son, William Herschel's son, and nephew of Caroline Herschel. He went to South Africa quite a lot, greatly extended what became the new general catalogue and filled it out with beautiful Southern Hemisphere objects as well. Anyway, Cameron goes on to say, finishes off by saying, this sounds like an ideal target for a half-meter telescope with its brilliant bright blue stars framing the spectacular red supergiant star at its core. So, in chat, opinions, please. We've got suggestions from. I think I know where this is going, but I'm not going to prejudge. I think I know where it's going. I know Carol has given her suggestions, Bernd has given his, and Cameron's got his. I don't know if there are any other suggestions that people wants to put in into chat. While I'm waiting for any responses on that, Roy has asked, will lunar images be flipped? No, they won't, because all images from Slooh's telescopes are presented north, up, east, left. It's quite counterintuitive. I know on one iteration of the website, when we showed lunar phases, we did show the graphics flipped as you see them in the Southern Hemisphere. And it's still a really counterintuitive thing for me when I do go down south. and stuff is kind of looking upside down, and also to see, more southerly constellations. I see Scorpius from the UK. Even the tail doesn't get above. The Stinger does, but part of its tail doesn't get above the horizon from where I am in the UK. Even Orion is quite low, for a lot of the year as well. So when I go down to the southern hemisphere and I see Orion or Scorpius high in the sky, it's absolutely, mind-boggling. I hope everybody who doesn't live in the southern hemisphere um, gets to see that. Right. I know there's some other questions and stuff coming in. So, Keith, will lunar missions be on A1? No, they will not, Keith, for the same reason that they're not on Canary 2 wide field and Canary 1, because even with using the H alpha filter and incredibly short exposures and flushing the CCD afterward, where we basically flood the CCD to get rid of what's called a residual ghost image. It's you still see, especially when you're on fuller moon phases, but you still see this ghost of the moon, and that totally wrecks any missions afterwards, sometimes for up to half an hour, especially if there are consecutive lunar missions using those telescopes. So we've still got we've got the Canary 2 ultra wide field, which gives the best full lunar disk views at the moment. Canary 4, when it's behaving, is providing some absolutely spectacular close-up shots. There were some shared observations of that over the last couple of weeks, and some of those been absolutely spectacular. So what have we got then? So we've got a couple of others. Waters suggesting the Pavo globular cluster in here. What else we got? Pointers, cameras saying looking superb in the all sky. Oh, right, let's have a look. Let's go over to the Australia one. So Cameron pointed out actually that in the post that I shared in Astronomers Anonymous, photo I used of the telescope in the Milky Way arching above, that you could actually see the globular cluster Omega Centauri right at the top of that. So if you go off and have a look at that post, do have a look at that, and you'll see it's bang smack in the center at the top of the image, which is quite cool. Keith is going for the jewel box. By the way, maybe in chat someone can tell me, because when I first saw this suggestion from Cameron, I didn't look it up. I should have done. Is this another jewel box, or is it the one that we've already got in the Slooh 1000? So someone can look that up if you like. So recommend, yeah, Waters going for the Trifid Nebula, absolute classic object, and I have to say I did run a test mission on that. Looks pretty cool. The dark lanes of dust on it look absolutely spectacular. And what else we got here? King ask a question in chat. Kane's asking, what are the options? The same one, I believe. Canary 4 is actually having a technical glitch. Yeah, so as I say, we're looking at it. It is in the Slooh 1000. So thank you, Carol, and thank you, Keith. So that's good to know. But we are going to be adding that star, Jinan. Hopefully, I'm pronouncing that right. So what's the deal here? We've got a few options. We've got the nebulae that Cameron mentioned. We've got the globular cluster. So let me just go through the list again. These are the only suggestions that we got. So globular cluster, Omega Centauri. We've then got Burns suggesting that we do that, and then we could go to the active galaxy Centaurus A, which always looks great. Cameron then says, yeah, there's a bundle of showcase southern hemisphere objects such as Carina and Eta Carinae nebulae, the Tarantula Nebula, and of course globular cluster 47 Tucanae. Now, some of this is going to change. You may have noticed that I had actually scheduled this star party in the launch of the Australian Observatory well after when missions would normally start, but that was only to give a break to some of our members and students in North and South America, so it wasn't in the absolute dead of night. I know it is for a lot of you anyway. Um, but then, of course, we've got Jinan the Star that we could do, and we've got the Jewel Box. So if only we had set up a poll for this, Gretchen, we could have done it officially. But if anybody is there, just open chat up and add which one of those you want to win that competition, and we will make sure, as best as we can, actually, because it will depend on when the telescope comes online, the first clear night. Um, we'll make sure that that is um, the first night. So we've got a couple of votes in for the jewel box. Thank you very much, Tony. For those of you who are into the asteroid and comet tracking business, don't forget Tony Evans is the guy who runs our course that teaches students and members how to track near Earth asteroids. You need to be an astronomer member for that, or you need to have a research grade student account, which is virtually the same as an astronomer account. But there is, you'll see on the guide page for Australia, um, it does have an existing Minor Planet Center observatory code EO9, but we will be requesting, and when I say we, Tony has very kindly suggested that he is going to get that new observatory code for us. Tony, no doubt, will also be doing some work on calibration for the bits of software that the Near Earth Asteroid team are using. So, got another vote in. We've got a vote for 47 Tucanae. We've got one for Omega Centauri. Come on, it's your time is running out. While we got that, any other questions before we announce that? And don't forget, you can go to the Astronomers Anonymous post and you can vote in there. We'll make a decision on that by the time we go live, actually, because that will depend on which of those objects is totally visible. So a plan to so Water is asking, is there a plan to have the filter for nebulae? If you're still talking about the H alpha no water, there won't be any use of narrowband filters on the Slooh telescopes. It just doesn't fit within a 5-minute mission. You need very long exposures to go through there and collect enough light. And frankly, the live images as well really don't look terrific. They need an awful lot of post processing to look good. What are we targeting at this time of year in Australia? Yep, ask that one. Yeah. So, any other questions, folks? Oh, so Kane, I don't know if you're suggesting that star, maybe the orange star, gaining. Um, so that would be cool, actually, wouldn't it? To actually have our first light object being a new object to the Slooh 1000. So it would be probably, unless somebody has scheduled a mission to that using the Chile 2 telescopes, using either one of the catalogs, the SAO catalog, or through coordinates, it would be the first time that bang, the Australia 1 telescope captures an object, but then it could capture an object which was brand new to the Slooh 1000. So thank you, Keith. Thank you very much. It's been a long ride. Thank you, everybody, for your patience. Jenny is voting. Thank you very much, Jenny. She's voting for Jinan 2. So I think that's 2 to that, 2 for Omega Centauri. You can change your votes if you wish. I love Cameron's reason for picking those objects. I think it's absolutely brilliant. So okay, so what listen, unless anybody's got any other questions, we will shut down this star party. I will hop over to admin. I'm going to block out actually a bundle of missions at the beginning of each night. Now, if we look at that weather forecast over the next week, it looks pretty darn unlikely that we're going to open during that time. And even when the all sky looks like this, we've still got, you can see the clouds there. You can also see down here the live telemetry as well. We've got 94% humidity and stuff like that. I have increased actually. We would normally be closing at about 80% humidity. We don't have dew heaters on this particular telescope because we don't normally need them in that location because the humidity is usually a lot lower when it's this high. I have increased the level just so that I could get through some testing. But it is going to be fairly unlikely that we're going to be open over the next week. So before you do schedule your missions, do please check the weather forecast, which is down here, and you just click that button to scroll through the days. Chance of rain, rain, partly cloudy, mostly cloudy, chance of rain, chance of rain. All right, so keep an eye on that. But I tell you, it will be well worth waiting. So, but what I'm going to do is I'm going to block out the first chunk of missions, maybe the first 10 missions each evening, so that when it is going to come online, we can make sure that whoever does win this, then that's going to be the first mission that Australia 1 captures. I'll just block it out so nobody can schedule other options in there. So Kane is saying, oh right, I thought you said the witch 1. Um, well, well, it looks like it's 2-all, doesn't it? Is it 2-all? Did I get that right, folks? Is it 2 for Omega Centauri, 2 for Jinan? What do you think? What do you think? Looks like it for me. Or is Jinan up to 3 now? I don't know. Gretchen, do you know? Have you totted up the numbers? Right, that's it.
I do not, but I will
Keith's
go
changed his vote to
to.
Jinan. Jinan is the winner. It's going to be a new Slooh 1000 object. That is going to be on the suggestion of Cameron McEwing, is going to be our first light object for the Australian Observatory. So that's great. Yeah, it's the new one, Kane. So excellent. Thank you very much, everybody, for that. Any other last questions? I did ask the SROF to get a very large fan and try and blow the clouds away today, but we wanted to go ahead with the launch anyway, and go through all of this information. So hopefully you found it quite useful to know this. I think somebody asked, did I see a question saying, what's the large radio telescope in this view? It's pretty damn cool, actually. When this is operating in the all-sky time-lapse, you see this huge radio telescope moving, and it's the MOPRA radio telescope at Siding Spring. So we've just got an alternative source of all-sky weather as well. So, okay, Hank's saying, okay, let's do Jinan too. Everybody's jumping on the bandwagon now. So I'm really pleased. I think it really deserves to be, as Cameron was saying, an object which is significant, and being in the Southern Cross, it very much is. I'll check the visibility of it as well. Thanks, Jeff. Thank you all for your patience while we've been getting the Australia Observatory online. The hardware was installed and actually commissioned last November, but the engineering team have had other priorities to be working on. Huge thanks, to Todd Resor and to Ed Kalin. Ed's been working furiously on the back end, especially with trying to operate a new roof, because that needs a whole stack of new programming and stuff like that. And Todd then does most of the front end work as well. Ed Kalin has been up all night, because it doesn't matter how much time and how much warning you have on a project like this. You always work a flat 24 or 36 hours right at the end, and Ed was left with all of those last minute tasks. We've got, I think the only thing which is outstanding now is the satellite image, which we've got, but is not displaying on the website. So anyway, that's it. Thank you very much, everybody from around the world. A lot of you need to go back to bed immediately and try and grab at least an hour's sleep if you can hold back your excitement of Slooh's new Australia 1 Observatory. Australia Observatory with the half-meter telescope down there. So keep an eye open. Chances are that the first time it opens, I will jump online, do a little live star party so that we can watch that together. There might not be that much warning for that, but I'll try and give you as much warning as possible. And everybody cross fingers for some better weather. But for now, thanks for joining me, everybody. Take care.